Okay, for the next subtopic, Taylor and also Maclaurin series. But for your syllabus, Taylor has been excluded, so we just focus on the Maclaurin series. Okay, so for the Maclaurin series, so this is the general formula. So you have to remember lah this formula. Okay, you have to memorize this formula, because this formula will not be given. So similar to the expansion of the power series, so that formula, the general formula that we have done just now, so you still have to memorize that formula. Okay, so now we move to example 5.18. So obtain Maclaurin series expansion for the first 4 term for exponent x and then 5 term of sine x, hence deduct that Maclaurin series is given by something. Okay, so first, so this is the Maclaurin series equal to f naught plus x f prime naught plus x squared over 2 factorial f double prime 0 plus x cubed over 3 factorial f 3 0 plus 1 2 3. Okay, so this is the general formula for the Maclaurin series. If let's say our fx is equal to sine x, so f0 equal to 0, sine 0 equal to 0. Okay, and then differentiate f, so we get cos x, so f prime 0 equal to 1. Differentiate again, so we get negative sine x d4 f double prime 0. Differentiate again, differentiate sine, we get cos but negative, so cos x f equal prime 0, so we get negative 1. Okay, and then substitute into the formula, the main formula, d4 sine x. Oh, the question asks for the 5 term, so 1 2 3 4 5. Okay, so because the question asks for the 5 term for the sine x, so so we need to expand until f 0. Okay, so here differentiate again, so you get sine x d4 f4 equal to 0. Okay, d4, the expansion for sine x equal to f0 equal to 0 prime, so x minus x cubed over 3 factorial plus blah blah blah. So this is the answer. Okay, I think because we cannot see the pattern, so you need to expand, because of the question asks for the 5 term. So if we do until x to the power of 4, we get until these 2 only, and if we want to expand, we cannot get a pattern. So what you need to do, so you need to continue for x5 to the power of 5 f4 0 plus x6 over 6 factorial f 6 0. Okay, so you have to expand, because like I said, if you want to continue the Maclaurin series for the sine x, we cannot get the pattern, so no choice. You have to add for the x power of 5 and also x to the power of 6. So f5 0 equal to cos x. So f prime equal to 1. Okay, so f6 x equal to negative sine x. So f6 equal to 0. So now expand, so we get, see, it's for 0, so 1. So plus x 5 over 5 factorial. Okay, now you get the pattern. So the question asks for the 5 term, so plus minus x to the power of 7 over 7 factorial plus x to the power of 9 over 9 factorial plus blah 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 1 2 3 4 5. Okay, so this is the pattern for the sine x. Okay, if the question asks you to find the Maclaurin series for the sine x, even though, okay, I would like to remind you, even though you can memorize this expansion, okay, even though you can memorize this expansion, but because of the question asks you to show, so you have to do all this step. Okay, from here to here, you need to show all this step. Okay, if you just give me the expansion, the Maclaurin series for the sine x here, so I will just give you the answer for A1, just the mark for answer, not for the method. So you have to show me how you get this one, even though you can remember the Maclaurin series for sine x. Okay. Okay, now for the exponent x, so exponent x, so now fx equal to exponent x, so f 0, exponent 0 equal to 1. Differentiate once, so you still get exponent x. So when you expand for the exponent x, you still will get the same answer, exponent x. Therefore f double prime x equal to f triple prime x. You still will get exponent x. Therefore when x equal to 0, triple prime 0, so you still get 1. Okay, therefore exponent x equal to 1 plus x plus x squared over 2 factorial plus x cubed over 3 factorial plus blah blah blah. Okay, and then the question asks for what is the exponent x sine x. For exponent x sine x equal to 1 plus x squared over 2 plus x cubed over 6, and then you times with x minus x cubed over 3 factorial plus x 5 factorial minus x power of 6 7 factorial plus x power of 9 over 9 factorial plus blah blah blah. So you expand, you have to expand this one. Okay, you expand one by one, so please be careful. And the question asks to show. Okay, so you expand this one and finally you will get this answer, x plus x squared plus 1 over 3x cubed minus 1 over 30 x to the power of 5. Okay, you will get this one. Okay, so you have to try this one. Okay. And 5.20, if y equal to ln cos x, show that hence by differentiating the above expression several times, obtain the Maclaurin series of y equal ln cos x in the extended power of x up to the term containing x4. Okay. Okay. So y equal to ln cos x. So differentiate once. So we get 1 over cos x, and then differentiate cos, we get negative sine x. So equal to negative sine over x, so negative tangent x, y double prime, so differentiate tangent, we get secant, so negative secant squared x. Therefore y double prime plus 1 plus y prime squared equal to 0. So we substitute negative secant squared x plus 1 plus y prime. Y prime is negative tangent x squared equal to 0. So negative secant squared x plus 1 plus tangent squared x equal to 0. Okay, now if you refer to the identity, okay, refer to the identity, 1 plus tangent squared x is similar to secant squared x. Okay, you have to refer to the list of formula. So get secant squared x to 0. Therefore left hand side is equal to right hand side. Okay, and then the question asks for hence by difference in the above equation 7 times obtain the Maclaurin series for y in the ascending order to the term of containing x to the power of 4. Okay. Now f(x) equal to ln cos x, and if f(x) equal to 0, so we get 0 prime x. So we have differentiate just now, we get negative tangent x, f prime 0, so we get 0. Differentiate again. So just now we get negative secant squared x, so f prime 0, so we get negative 1, and then differentiate again. So differentiate secant, so negative 2 secant x, and then differentiate secant, we get secant x tangent x, therefore x tangent x, f prime 0 equal to 0. Okay. And f to the power of 4, differentiate again. So now we have to do product rule lah. Okay, we have to apply for the product rule. So u is equal to secant squared x, so u prime is equal to 2 secant x, differentiate secant, so we get tangent x, and v equal to tangent x, so v prime is equal to secant squared x. Therefore when we differentiate I'm so sorry so u v prime, so secant 4x plus VU times 2 secant squared x tangent squared x. When f4 0, so you get negative 2, negative secant. So using your calculator, so you will get negative 2. Okay, you get negative 2. Therefore, for the ln cos x equal to negative x squared over 2 factorial, and then plus, so mine plus x power of 4 over 4 factorial negative 2. So the answer is negative x squared over 2 minus x4 the power of 12. Blah, blah, blah. So this is the answer. Okay, because the question asks the Maclaurin series up until term x4. So this is the answer. Okay. Right. Okay. For the next subtopic, we want to find the limit with Taylor and Maclaurin. So Taylor, we don't want to use Taylor, so we just focus on the Maclaurin. Okay. So, example 5.21. Okay, find limit x approaching 0, exponent x minus 1 minus x over x squared. Okay, so for this question, actually the question asks by using the Maclaurin series. So first, what you need to do, you need to find what is the Maclaurin series for the exponent x. Okay, you need to find what is the Maclaurin series for the exponent x, like what we did just now here. So this is the Maclaurin series for the exponent x. So sorry. Therefore, limit when x approaching 0, exponent x minus 1 minus x over x squared is equal to limit when x approaching 0. So 1 plus x squared over 2 plus x cubed over 6 plus blah 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 minus 1 minus x and then over x squared to limit when x approaching 0. So 1 minus 1, so x minus x, so x squared over 2 plus x cubed over 6 plus blah blah over x squared equal to limit when x approaching 0. So x squared over 2 divided by x squared, so you get 1 over 2 plus x over 6. And then when you substitute, when limit x approaching 0, so the answer will be 1 over 2. So this is the answer. Okay. And for the second example 5.22, so we have limit x approaching 0 for the x squared plus 2 cos x. So the cos x, you need to find what is the Maclaurin series for the cos x. So what is the Maclaurin series for the cos x? We have the cos x. Oh, this one sin x. So you need to find lah what is the Maclaurin series for the cos x. Okay. So cos x is equal to 1 minus x squared over 2 plus x4 over 24 minus x6 over 720. Okay, so this is the Maclaurin series for the cos x. Actually this one you have to show lah. You have to show how you get this one. Okay, by using the Maclaurin series. Therefore, limit x approaching 0, x squared plus 2 cos x minus 2 over x4 equal to limit x approaching 0, x squared plus 2 over cos x, the Maclaurin series for the cos x, over 720 minus 2 over x4. Limit when x approaching 0, so x squared so 2 minus 2 and then negative x squared over 2x squared. Okay, so you will have x to the power of 4 over 12 minus x6 720 divided by 2, so 360 over the x to the power of 4. So limit when x approaching 0, so you get 1 over 1 times 12 times 3, so 36 minus x squared over 360 times with a, so you get 1080. So when limit x equal to 0, so final answer is 1 over 36. So this is your answer. Okay, and then for the next one, so we want to evaluate the by using the integral, but now still using the Maclaurin series. So example 5.20. So A, integrate to 1 exponent negative x squared dx. Okay, so we have the Maclaurin series for the exponent x go to 1 plus x squared over 2 plus x cubed over 3 factorial plus x4 over 4 factorial. Okay, so this one for the x, but the question is exponent x squared. Okay, so you need to change all x to negative x squared, so plus 1 plus, okay, x now change to negative x squared plus negative x squared over 2 plus negative x squared cube over 6 plus negative x squared 4 over 24. So is 1 minus x squared plus x4 over 2 minus x6 over 6 plus x power of 8 over 24. Okay, 24. Integrate from 0 to 1, exponent negative x squared dx equal to 1. 1 minus x squared plus x to the power of 4 over 2 minus x power of 6 over 6 plus x power of 8, 24 plus blah dx. So integrate. So x minus x cubed p plus x to the power of 5 over 10 minus x power of 7 over 42 plus x power of 9. So 9 times with 24. 0 to 1. By using your calculator, 1 minus 1 over 3 plus 1 over 10 minus 1 over 42 plus 1 over 9 times with 24 minus so you will get 0.7475. Okay, yeah, similar to this one. So 3 decimal places, so equal to 0.74. Okay, from my calculator, if 3 decimal places, yes. Okay, this is from the calculator. Okay, but this one if they want 4 decimal places. Okay, so this one, can you do it on your own? Just to get this answer. Okay.